Here are the solutions to quiz number 2 for ECE 321, Analog Electronics. Now the first problem is a thermistor problem. Assuming about a thermistor where I read 6.73 volts, what is the resistance? What is the temperature? Well, from voltage division, I know that the voltage is R over R plus 1314. For me, this is 1314 ohms times 10 volts. Solving backwards, the thermistor is the voltage over 10 minus voltage times R, 2704 ohms. Plugging in 2704 into the thermistor equation and solving for temperature gives you 16.329 degrees Celsius. For problem number 2, design a circuit that outputs 0 to 10 volts as temperature goes between 0 and 40 degrees Celsius. To do that, I first need to find at 0 degrees Celsius, find the resistance. Here's a voltage divider. That's 1314 ohms, so VA is 7.9 volts, and the output should be 0. At 40 C, R is 1234 ohms from the thermistor equation. Doing voltage division, VA is 4.88 volts. So this goes to 0 volts, this goes to 10 volts. As the input goes down, the output goes up, so connect to the minus input. I want the output to be 0 at 7.92 volts, so there's your offset. And the gain that I need is change in output over change in input. The gain I need is 3.24, so pick these resistors to be 3.24 to 1, giving you a circuit that outputs 0 to 10 volts as temperature goes from 0 to 40 Celsius. Problem 3 is come up with a low-pass filter. So for me, this is S plus 5, S plus 14. This is a 3-stage RC filter. Due to making the resistors 10 times larger, there's not too much loading. So here I want one over RC to be 3. I know R, solve for C, 333 microfarads. One over RC is 5. R is 10K, solve for C. C is 20 microfarads. 1 over RC is 14, for May 14th. 714 nanofards. To find R4, find the DC gain. Plug in S equals 0. That's what the DC gain should be. DC gain should be 47.62. So pick the resistor, so 1 plus R4 over 1K over 100K is 47.62. So R4 is 4.6 megaohms. Problem 4. Build a filter with poles that are complex. For me, I want the poles at 5 plus minus J14. To do that, I'll convert this to polar form. The poles at 14 at 70 degrees. 14 is 1 over RC. So here's the real pole. 1 over RC equals 3, giving you C1. 1 over RC is 14.87. Solving, it gives you 6.72 microfarads. To find R3, that comes from the angle. The angle goes 3 minus K is 2 times the cosine of the angle of the pole. The angle of the pole is, there it is, 70 degrees. Plugging it in, K should be 2.32. And that's 1 plus R1 over 100K for R3. So for gain of 2.32, I want a resistor of 132K. Finally, to find the gain, I want the gain of the system to be 15.08 at DC. This has a gain of 2.32. So the output is smaller than it should be. The output is only 0.154 times what it should be. So the scalar on the output is 0.15. Problem 5. Given a filter, that's S plus 5, S plus 14, find X, or find Y given X. Here I use superposition. At DC, X equals 5. This is the gain everywhere. All I care about is what's the gain at S equals 0, or DC, times the input, gives me 238. That's the DC output at DC. At 2 radians per second, this is the gain everywhere. I just care about what's the gain at 2 radians per second times the input at 2 radians per second. real parts cosine minus j as sine. Multiply it all out to get a complex number. The real parts cosine minus j as sine. So here's the total answer. And the last problem, given the gain versus frequency, what's the transfer function? Well, I know there's a 0 at s equals 0. I know there's a pole. Complex part is J20. Another pole, the resonance tells me the complex part is at 69. Go down 0.7 of the peak and measure the bandwidth. That's twice the real part. So here it said the real part's bandwidth is about 7, so the real part's half that, 3.5. Here the bandwidth is about 10, so the real part is half that, 5. So there's your transfer function. K is just a gain to match the gain somewhere. Probably pick K to make the gain at 20 equal to 1. And that's G of S. So that's quiz number 2 for ECE 321.